Let us discuss a question from thermodynamics. You have a oxygen in a perfectly insulated tank. So initially you have oxygen on one side of the partition, and it's a perfectly insulated tank, so there is no heat transfer. Okay, and two parts of the containing oxygen. Okay, and separated by partition. So now the change in entropy of the oxygen. So if you consider our system as these two together, okay, so if you consider that is our system. Now changing entropy always can be, we can use TdS equation. So there is du plus pdv, and there is one TdS equation which is dH minus vdp. So depending on whether pressure is 0 or volume is 0, you can use it. Now you should understand that, so we can begin with any of the equations. So let's start with this equation. Now you can see that because our system is this and there is no work done by the system, let's apply the first law. There is no work done by the system because it's a free expansion, okay, and it is completely insulation, so there is no heat transfer. So the internal energy change is 0. u1 by u2 is u1 is equal to u2. So this tends to be 0 from the first law because work done is 0, free expansion, and it's insulated. So TdS is basically pdv and ds is pdv by t. Okay, so now it's oxygen, so we assume that it's ideal gas, and for ideal gas we can write pv is equal to mRT. Remember that this r is the gas constant, so p by t is basically mr by v dv is ds. So everything we have brought in terms of dv by v. So now it's time for integration. S2 minus S1 is mr is constant, is integral dv by v, which is ln v2 by v1. Okay, so mass is something we need to find out per kg mass if you look at the units. So r is gas constant, which is universal gas constant by molecular weight, okay, into ln, the final volume is twice the initial volume, so ln2. Universal gas constant is 8.13 kilojoules, okay, per kg kilomole kg mole. So mole molecular weight is 32, is 32 kg per kilomole, right? It's 32 kg per kilomole, so that is 32 ln2. So it's 8.314 by 32 into ln2. So by this you get, if you calculate, you get 0.18. So it's kilojoules per kg Kelvin. Kilojoule because you are not, it's 8.31 kilojoules, okay, per kilomole. So per kilomole, what is the mass that you have to substitute, which is 32 for oxygen. Okay, so only trick here is first derive. This is a good question. First you derive the expression of the entropy in terms of what is known. So volume is something only which is known. So you use all that, changing internal energy to be 0, ideal gas equation, all that you use, you derive an equation. Now the another small catch is that the gas constant is universal gas constant by molecular weight, so that is important. So 0.18 kilojoules, and it increases, so that's why positive. Thank you.